Okay, let's do one more example where it's not already factored for us this time. So we're going to need to factor all of these quadratics to be able to reduce and figure out what our restrictions are. Now, these are all a equals 1 trinomials, so we should be able to factor all of these in one step if they factor. Okay, so this first one, what multiplies to 28 adds to negative 11? Well, 4 and 7 make 28, and if they're both negative, you get negative 11. So negative 4, negative 7. This is a perfect square, this is a perfect square, which makes that a difference of squares. So x minus 7, x plus 7. This one here, what multiplies to 35 adds to 2. Since it's a negative, we're going to get one of them negative, one of them positive, and get a difference of 2. So 5 times 7 multiplies to 35 and has a difference of 2. And we need to get a positive 2 term, so I need our 7 to be bigger than our 5. So it's positive 7, negative 5. This one here is actually a perfect square. 16 is 4 squared. And 8 is double 4. So this is going to be x and 4 squared. And since this is minus, this is going to be minus as well. All right, so let's just jump right into simplifying what we can. We've got an x minus 7 here and x minus 7 there. Those are going to reduce. We've got an x plus 7 there. We've got an x plus 7 here. Those are going to reduce. We've got an x minus 4 up here, which is going to reduce one of our x minus 4s underneath. So this simplifies to x minus 5 over x minus 4. And all we're left to do is state our restrictions. So from this term, we have x minus 7. So x cannot equal 7. X plus 7, when you bring the positive 7 to the other side, it becomes negative 7. And this negative 4, when you bring to the other side, is positive 4. And I suppose if we want to get fancy, we could rewrite this in ascending order. Negative 7, 4, and 7. But I don't know. I don't really care. Most teachers seem not to care what order you write them in. Oops. I accidentally scrolled over there. Order doesn't seem to matter too much, so long as you get all your non-permissible values. And there you have it. That's how you solve or simplify a rational multiplication where you need to factor.